going to continue with 1.5 application problems. We're going to do the last part of number 33. We're going to do part C. Okay, so part C says, use the graph of the function below to determine the dimensions that yield the maximum volume. We'll also mention something about the graphing calculator as well. Okay, they're asking for the maximum volume. So if you recall, here's the volume that we found in part A. Right now we're doing part C, by the way. So in part A, we found the volume to be 144x minus 48x squared plus 4x cubed. And that's centimeters cubed because it's a three-dimensional figure. Okay, what they did on this particular graph is they graphed x along the x-axis. Along the y-axis, they actually graphed v of x. And if you take a look at the coordinates, they went from 0 to 6 because of the domain that we found for part B, and from 0 to 200 for the y. Now if you look at, we're looking at the maximum volume. The maximum volume is the peaks. The maximum volume would be actually right here. Remember, the volume is a y-coordinate, so the maximum volume would actually be 128. Okay, what they ask us to do is to use this graph to determine the dimensions that yield the maximum volume. So let's draw down that picture that we had a little bit earlier in part A. This is our box, our three-dimensional figure here. And if you remember from part A, this represents the distance 12 minus 2x. This also represents 12 minus 2x. And then this represents x. Okay, so if I want to say these three figures, what the actual measurements are, I know that x is 2. 12 minus 2x, I'm going to plug in 2 for x. I get 12 minus 2 times 2. 12 minus 4 gives me 8. And then this also gives me 8. So the dimensions would be 2 centimeters by 8 centimeters by 8 centimeters. Okay, now we're going to continue with this, and now what we're going to do is we're going to talk about something about the graphing calculator relating to this. So I'm going to pull up my graphing calculator, and I'm going to graph this function right here, and I'm going to use the window that's listed right here. And then we're going to actually find the volume. I'm sorry, we're going to find the maximum using our calculator. Okay, so I'm going to go ahead and plug in that function that we had written down that's behind the calculator. 144x minus 48x squared plus 4x cubed. Okay, so again, that represents the volume of the three-dimensional box. And then what I'm going to do is I'm going to change my window. I'm going to use the same window as what I have. Whoops. Same window as what I have right here in my picture. Okay, so for my window, I'm going to go from 0 to 6 for x with increments of 1. And then for my y, I'm going to go from 0 to 200 with increments of 50. Okay, now let me graph it. So this looks exactly like the picture to the left. And we're going to find this maximum using our calculator. Now the way we do that is we have this calc button up here. So what we're going to do is we're going to hit second, calc. There's a minimum, a maximum. There's many other functions on here, but we're going to use a maximum because we're looking for the maximum. So go down to maximum. Okay. The maximum's right here. It says left bound. What that means is you won't go to the left of this maximum. So I'm going to use my arrow key until I'm to the left of the max. Okay, anywhere to the left, I hit enter. It'll say right bound. I'm going to go somewhere to the right of the max. Hit enter again. It will say guess. You just hit enter one more time. And then it will actually give you the maximum. If you look, the calculator is not perfect. If you take a look at the answer that they give you, it says 128, and here it says 1.999. If you round that, that's 2. So this right here corresponds to the 0.2 128. So again, our calculator is not exact, but it does give us a good estimate of the maximum. If you want to take a calculus class, you will learn more about maximums there. Okay, so this concludes number 33 from 1.55. The next video we'll go over number 25.